Hello and welcome to Unit 2 of Software Quality Assurance. In this unit we'll be talking about software requirements. In the book we're reading Chapter 4 and we're really just reading the first few pages of Chapter 4, and then I've added in Blackboard a few articles to read too. So the book talks about transforming requirements to testable cases, and we're going to split this up into two units. So this unit we're going to talk about the first step, which is creating software requirements. So without good software requirements, it's hard to create good testable cases. So this unit will talk about software requirements, and then next unit we'll talk about how to create testable cases from those requirements. So the book talks about the importance of software requirements. And if you look on page 52, there's a chart there, and it shows the correlation between the time spent on software requirements and the cost overrun of a project. As you can see by the chart, and you can imagine, the more time you spend on your software requirements up front, the more successful your project's going to be. And that can be measured by less cost overrun, better final project, and then less maintenance once that product is in place. The chart is a little ironic because if you notice, one axis is the percent of time spent on the requirements process, and then the other axis is the percentage of cost overrun. And there isn't a single project that didn't have cost overrun, so they seem to be saying you're always going to have cost overrun, but the goal is to minimize that as much as possible. So of course, the more time you spend up front on gathering those software requirements, the better off you're going to be in the long run. So the book talks about several quality factors, and I'm not going to hold you to a certain list of quality factors. So the book mentions several. Each of those articles mentions some of these ones, some other ones. So depending on your source, which textbook you use, which article you look at, there's going to be different quality factors. So there's not like a definitive list, but we'll talk about the ones that the book mentions here. And then as we go through the articles, we'll talk about some other ones as well. So first off, to write a good software requirement needs to be understandable. So you want to be writing a software requirement for that any audience could read it and understand it. So not just a technical person, but also a user or a manager as well. And when we write our software requirements, it's good to organize them. And there's a few different ways we can do that. So one way is to organize them by object. So if you've got some sort of business system, you probably have some sort of customer using it. They're maybe placing orders. You need to invoice those customers. So whatever system you're using, you can organize those requirements by the different objects, the different nouns you would think of with that system. Another way to organize your requirements is by process. And so think about the actions that happen in your system. So a customer places an order. There's a few things that have to happen for that. Later on, an accountant creates an invoice. There's a few things that have to happen for that. So the people designing the system will be thinking about both of these types of organization. So you know from your object-oriented programming classes, Java 2, that you need to make a class for each of the objects in a system. So you would have a customer class, an order class, an invoice class. So you would want your requirements organized by object. But you also need to think about the processes that happen, and when it comes time to test these processes, then you want your requirements organized by process. So you can go through and test all the requirements by going through that entire process. So usually you want to organize your requirements by both of these things. So you might have two ways of organizing them. Another thing to think about is the functional requirements and the non-functional requirements. And we're going to focus on functional requirements now. We will get into non-functional requirements later on this semester, I believe in Unit 7. But those are important as well. And we'll talk a little bit about those in one of the articles in this unit. And the other thing that it's important to organize your requirements by is the level of detail. And when you're working with users and gathering requirements, they're going to throw a lot of things at you. And some will be high level, some will be low level, some might be in the middle, medium level. And you need to gather all those, but to start off with, you just need to work at a high level. And so a lot of times you make several passes at the requirements. So the first pass, you're just gathering those high level ones. What is it that the system needs to do? And then once you start working on a module, then you can get into the medium and the lower level requirements. So a lot of times it's difficult for users and people gathering requirements to get past those low-level details. So at the very beginning of the process, you don't need to worry about what color something's going to be on a screen, or if data is stored in a common delimited file, or anything like that. You just need to worry about the high-level details, and then you'll get to the lower-level ones as the process continues. And in some further units, we'll talk about the different software development processes, so the waterfall model and the agile model. Use correct style and grammar. We'll talk about that in a little bit in one of the articles. And imperatives. We'll also talk. One of the articles goes into a little more detail about the different types of words to use. So that's the understandable quality factor that the book mentions. So some other ones. Your software requirements must be necessary. So sometimes your users might be adamant about particular aspects of the program, but they all need to relate to some sort of business process, so some sort of business goal. So sometimes you can get some other requirements that filter in that don't really have, somebody might really want it, but it may not relate directly to a business goal. And so everything should be relating directly to that business process and the system that you are building. We'll see as we get into the agile process that requirements can change over time, that they do change over time. And so if you've got a rigid requirement structure, it can be hard to handle those types of changes that happen. Requirements should be non-redundant. So sometimes you work with different users, they might state things differently. You might get two different requirements that actually at the root of it are the same thing. And so when you gather all your requirements, you're going to have to go through those requirements you got from different sources and filter out the duplicates, or possibly write a requirement that covers two of those related things. Terse is good. So the simpler the better. This is true in education as well. The longer somebody talks in a presentation, the less likely that they are being clear. So be simple, be brief, and be done. Testable. So, and this is what we're going to work on the next unit, is how do you test your software requirements. So when you write your requirements, you have to think about, how am I going to test this? And how are we going to decide if the system meets this goal? So when we're all done here with a certain module, we're going to test that module to see if it works. And how are you going to accomplish that? So there has to be some sort of definitive way to say, yes, this software meets this requirement, or no, this software doesn't meet this requirement. Your requirements need to be traceable. So you're going to have a lot of documentation in your project, and you want to be able to tie back a lot of things to this particular requirement. So you might need to have an ID on this requirement. And that ID might, depending on your numbering system, it might indicate who requested that requirement. It might indicate where it fits into the overall project. So what object does it relate to? What process does it relate to? And then you'll use that ID for your test cases. So your test cases need to be tied directly to a software requirement. You're not going to have test cases that don't relate to anything. So everything that's generated from the software requirement is going to carry that ID with it. And then that way you can trace the software requirement through the whole software development process. And also your requirements need to be within scope. So sometimes you can get scope creep with your users. Users oftentimes want a lot of functionality, but you need to clearly define what the boundaries of the work of your project are. So even if something's a very desirable software requirement, it may not be in scope for this project. Now, it doesn't mean you're not going to have another phase of this project. So a lot of times projects are in several phases, so you just need to clearly define for this phase what we're going to do. And you might do something else, later, but we need to just define the current phase that we are on. Okay, so that was the content in the book, and I want to jump into some of the other articles I posted on Blackboard. So it was 4 different articles. So the first one, A Short Guide to Writing Software Requirements, mentions a couple key things I want to cover. So all 4 of the articles, there's some overlap there, and there's some of the articles mention some things that we won't cover as much, but I'll just highlight some key things in each article that I'd like you to focus on. So one of the points in this article, so this is the first article in Blackboard, is that requirements are emergent. And so we mentioned previously in the book said that requirements need to be modifiable. So requirements are going to change, and in a couple of units we'll talk about the agile software development process. And you may have covered this in a software design class or a systems analysis and design class. the agile process for developing software. But requirements can change as you get into the project. They can expand, they can say, they can contract, and maybe we don't need quite as much as we thought we did. They can change completely, they can be deleted. So what you start off with may not be what you will end up with. And the other thing is it's impossible to think of all the requirements at once. And in the traditional model of software development, the waterfall model, we would try to think of all the requirements at once and then stick with that and then go and develop our software to meet those requirements. But that is very hard to do unless you have a kind of a simple system or a very well-defined system that you've worked on a lot. It's impossible. It's very hard to think of all those requirements at once. So it's better to kind of have a loose document of requirements, knowing that those requirements are going to change and be added to and be removed. Some different components then of requirements. So there's high-level ones that we talked about, low-level ones. It's important to identify where your requirements fit into those levels. Because if it's a very low-level requirement, you may not have to worry about that to start off with. So just focus on those high-level ones to begin with. And then as you work on each module, then you'll get into those lower-level requirements. So this article mentions a few other things that you would create along with your software requirements. So you'd have workflow diagrams. Those show the business logic of what's going to happen in your program. You have wireframes that show graphically what that user interface should look like. And you would have the possible inputs for that module and then what you would expect the outputs to be. That would be directly related to what you would be testing then. So here's some inputs I want to test and here's what I would expect for the outputs. So a lot of these things you'll talk about in systems analysis and design, or perhaps you've taken that class already. And so you talk about workflow diagrams and wireframes. And so we're not really going to get into that, but just know that there's a lot of supplementary documentation you would work on as part of your designing your software requirements. The possible inputs and expected outputs we will talk about next unit because that's related directly to software testing. And lastly, this article mentions user stories. And so this is the next step after creating your software requirements. And again, we're not going to get into user stories too much. That would be in your systems analysis and design class. But part of when they talk about user stories, they talk about conditions of satisfaction. And so this is something that's going to be related to us in our quality assurance class. So we have to think about, again, the testability. So what are the criteria that this software requirement needs to fulfill? Or what are the criteria that this software needs to fulfill to pass this software requirement? So we're going to think about all the different types of users using this system. So it's easy to think about a normal user. Typically for any type of system, you're going to have a user. You're going to have probably some sort of admin that can go in and set things up. But what about users that are deactivated? Maybe they're no longer active. Maybe they're no longer part of the company, but you still need to keep track of them. So you might have deactivated users or deleted users, or maybe some sort of special admin user that does some sort of special tasks. So think about all those different types of users, because if you don't, you might be missing important aspects of the system. And then based on those software requirements, how are you, the condition of satisfaction is, and what makes this software requirement satisfied? Because that's what you're going to need to know. That's what you need to test later on. And this article shows some examples of that with a password. So those are some good examples to look at and think about when you are writing your software requirements, which you will do for your assignment in this unit. The next article, the second one, is called Gathering Requirements and Creating Use Cases. And again, we're not going to talk about use cases in this unit, but I wanted to highlight a few things from this article. So first of all, the importance of software requirements. You can see the article starts off as saying 40 to 60% of all software defects stem from the errors and requirements. And that's so true that software errors, a lot of software errors aren't just a typo or the developer misunderstanding something. A lot of that misunderstanding comes directly from the root of the project, from when we first started working on it. So half of your errors are going to be in this stemming from the software requirements. So you gathered a requirement and you wrote it up, but it's not what was actually required by the user. And so that's what we're really focusing on this unit, is writing good software requirements to minimize these types of errors. And lastly, the book mentioned this too. It seems to be pretty common in the software development world, at least for um, development shops that aren't very formal, that there's a little bit of time spent on requirements, talking to the users, and then people just jump right into coding. And that's the equivalent of just talking to somebody about what kind of house they want for a little bit, and then just jumping in and grabbing some 2x4s and some concrete and going to town and kind of seeing what you end up with. And so you wouldn't build a house without a plan, so you really need to have a solid plan for your. You need to have a lot of good software requirements. And so the more time you spend to that up front, the better off you'll be in the long term. And this article goes into a little more detail about the functional requirements and the non-functional requirements. So the functional requirements are, what is the software going to do? What are those specific tasks? How will that software function? And that can include the data that this software uses and the business rules, the logic that we're programming in this software. Their non-functional requirements are just as important. So the non-functional requirements would be the visual things, the user interface, the performance. So how many people are going to be using it? Are 5 people using this, or are a million people using it? That makes a big difference in how the system will be designed. Any system needs to be changed and needs to be maintained over time. So the maintainability of a system. Some other ones are portability. So can the system run on different computers, Linux computers, Windows computers, phones? Security is another one. So how strong security do we need? What is that security? What are those security requirements? So we'll get into these in Unit 7 later on this semester. So right now we're just focusing on functional requirements. And then the last point I wanted to highlight from this article is it's the business analyst that's going to be doing this job of gathering requirements. So I believe all of you are probably in the business analyst concentration if you're taking this class. And so when you're working in the business world as a business analyst, this is one of the important tasks you'll be doing, is writing software requirements. So less so if you're a software developer, but it's still important to know this process because you'll be working with software requirements. Okay, the third article is software requirements specification by example. And so they've got some good examples and bad examples, which I think are great things to look at. So you'll be writing your own software requirements as an assignment for this unit. So I would look at this article and take a look at their good examples and bad examples to kind of get an idea of how to go about writing your software requirements. Now, they break it down into some other categories. They talk about some different things in the book, but we'll just talk about them briefly here. So they say that software requirements should be definitive. So you don't want to have ambiguity. So the more vague a requirement is, the less likely it's going to be successful and less likely you're going to be able to test it. So it needs to be definitive, no ambiguity. Verifiable, again, we need to be able to check to see that this requirement is met. Explicit, so don't assume that everybody knows what you're talking about when you're writing a software requirement. So think about who will be reading this requirement, and think about somebody who's not technical, a user, a manager. So you need to write your requirements that anybody can understand them, and so you need to really spell out any assumptions that you're making. Simple is best. We mentioned this one before. If you were talking about a complicated concept, just split it into smaller tasks. So the longer, if you have to write 2 paragraphs for a software requirement, it's way too big. So think about a requirement that you can write in 1 sentence, 1 or 2 sentences. Self-sufficient, sometimes with larger concepts, if you split your requirements, they can all get kind of mushed together in order to accomplish their tasks. So when you split up your big requirements into smaller ones, make sure that each requirement is valuable by itself. So each requirement is its own standalone piece of the program. So you shouldn't have a software requirement that requires 3 other requirements in order to make it valuable. You'll have a lot of related software requirements, but each requirement should be able to stand on its own. Implementable means feasible. So can it be accomplished? And then the last one is the business and product oriented. And we talked about that your software requirements should be directly related to this system. And it shouldn't be related to any certain technology. We'll talk about that in a little bit. It shouldn't be related to any personal goals of the people requesting the requirements, but it should be related directly to the business goal of the system and the product that it's working on. Okay, and then next we have the 21 top engineering tips for writing an exceptionally clear requirements document. So we won't cover all 21, but I wanted to highlight some of the important ones that we haven't talked about yet. And I think this, so this article is written by a company that works, all they do is software requirements, and they have software that helps that process. And so they're experts in software requirements. And I really like these tips that they came up with. So they, based on their own experience, and then they surveyed some software engineers as well. And these are the tips that they came up with. Some of them we've already talked about, but I'll highlight a few here. So number 4 of the 21 tips, standardize your requirements document language. You've probably run into this if you've done some business writing as well. When you start to write about a project, you need to figure out what's the vocabulary we're going to use, and we need to use those words consistently. To give you an example, we have this issue as teachers as well. So when we're creating content in Blackboard, we have to think about what is the vocabulary we're going to be using, both for the content we're writing and just for the educational components. So for instance, the start of semester, or when I design a course, I need to decide, am I having quizzes or tests or exams? And if I say, okay, I'm going to have I'm going to use the word exams. I'm going to use 2 midterm exams and a final exam. Then I need to make sure I use those words consistently throughout the course. And so I shouldn't say exams in my syllabus and then in Unit 6 saying, okay, we have a quiz. So if I decide that my evaluations are called exams, then I need to stick with that. So same thing too for writing about a software system. Choose the vocabulary words that you're going to use. There might be several different ones that kind of all mean some similar things. Choose one and then define that. And then you might even need to create a glossary to define those words, because you're going to have a lot of different people looking at this document. You're going to have users, you're going to have managers, you're going to have software developers, you're going to have business analysts, you're going to have software testers, and so everybody needs to be on the same page about what these words mean. So the book mentioned the word shall as well. So be consistent with imperatives, and this is tip number 5. And so there's a convention of certain words that we use when writing software requirements. So shall is considered a binding word, meaning that this requirement is a requirement and needs to happen. Should and may are considered not binding, that these are optional requirements. So probably you want all your requirements to use the word shall, because probably these are all binding. It may be that you may have a few requirements that are optional, so it'd be nice if we could do these if there's time. As you saw in the book's chart, the amount of, according to them, the amount of software projects that have overruns is 100%. So every software project goes over the time and money allowed. So the odds of actually completing a optional software requirement are probably not very large. But so probably you want all your requirements to be binding, and then you would be using the word shall. And then also, we talk about functional and non-functional requirements. So you use shall for functional requirements and must for non-functional requirements. Do you have to use these words? No, it's kind of up to you and the company that you're working for. But these are the conventions that are out there in the software quality assurance world. Tip number 6. So make sure each requirement is testable. And so we've mentioned this a couple times now. But this is directly related to what we'll be doing this semester. So when you've got a software requirement, you need to think about, how are we going to test it? How are we going to know if we met this software requirement? And if you can't think of a definitive way to say, yes, so we met this goal, no, we did not, then that means you probably need to rewrite that requirement or just not have it. So think about ways that you can put some measurables on that requirement so you can know if you meet it or not. Okay, number 7 from this article, tip number 7, write functional requirements to be implementation neutral. One of the other articles mentioned this as well, and I really wanted to stress this here. When you're working with users, you're going to get your software requirements from your users and from your managers. All they should care about is what the program does, that the program meets their end goals. But how the program accomplishes that is not up to them. That's going to be up to the IT folks, the technical folks, the software engineer. And you shouldn't decide anything about how a program works, the technology uses. You shouldn't decide anything until you've got all your software requirements. So if you just look at one requirement and say, oh, you know what, I bet we could do this with Java, or we could do this with .NET, or we could use this with Excel. That might be true, but you're not going to decide your technology or the way you're going to accomplish something until you see all the requirements. because then you have a global view of what the system needs to do and then what the best way to accomplish it is. So all your requirements should only focus on what the system should do, not how it should be done. That's not the job of the users to determine how the process is going to work. That's the job of the people implementing the system. And if you're really married to a particular way of doing things, you're really, that second bullet point there, you're going to bind yourself to one method that may not be the best method globally. And so really keep an open mind about how something can be accomplished. Don't even be thinking about how it can be accomplished at this point when you're writing your software requirements. And that last bullet point, then a good way to think about this is just think about the user interface and just how you would know that something is accomplished. And so if the user clicks a button to send invoices, how will that person know the invoices are sent out? So maybe it's a pop-up box that says this number, or maybe there's a report that's run. That's what you'll use to test it, is just to see what that externally observable behavior is. Not you won't these people won't at all be looking at behind the scenes how that's actually accomplished. Tip number 8, the rationale statements are appreciated. So besides writing the requirements, a lot of times you can include a separate little note explaining the rationale for that requirement. It's separate from the requirement, so your requirement should still be simple and simply stated, so maybe a sentence or two. So you're not going to want to write a 2-paragraph long software requirement. But in addition to that simple software requirement, you could include a paragraph about why we have this requirement. So who is requesting it and why it's important. And a lot of times that rationale is forgotten. So a software development project could take months or years. And a lot of times after several months or after a year, you might forget, why did we require this, or what were we going to use this for, or why was this important? And so it can be nice to document that, so you've got that. And then the software developers or the people deciding what they work on next can see kind of, okay, well, I see why this is important. And without that rationale, sometimes it can be hard for people to choose what the important requirements are and which ones are less important. And then lastly, the last tip is the writing style and grammar. So if you've taken any sort of technical writing course or business communication course, you may have seen some of these points. So don't use weak words, avoid the passive voice. So you want to have strong words, and you want to use the active voice. And then don't speak in the negative tense. So use positive requirements. So write a requirement the way you think about it, but then if you see yourself using negative terms, just see if you can flip it around and speak positively. So that's just a brief kind of summary of some of these are all things that you may have seen in some other classes if you've taken management communications or some of those business writing courses. So, okay, so that's a summary of the material for Unit 2. So there's just a few pages in the book on this, and then we've got those 4 other articles to kind of give you an idea of what we're talking about with software requirements. And as I mentioned, there's really a whole lot of different things that would go along with software requirements and user stories and use cases and that type of thing. You'll cover all that in a systems analysis and design class. But for this short 8-week course, I just want to talk about software requirements, how to write good ones, and then the next step then is to create your tests from those requirements, and that's what we'll talk about next week.